Hi, how are you? This is the final lecture of the geometry unit. So today we study optimization. So what is optimization? It means you need to get the either the greatest or you want to spend the least. Okay, so that is optimization. So now the first situation is this. So for example, here all these shapes are rectangles, right? And each rectangle has a perimeter of 64 units. And then which one has the greatest area? So this is to get the largest area. So how can you get the largest area with a given fence, a given perimeter of the fence? Okay. So for example, this one, it has a perimeter of 64 units. Here the length is 30. So the other length is also 30, right? So 30 plus 30 is 60. Plus 2, the width is 2, plus 2, and then plus 2, then it is 64, right? So how much is the area? The area is 30 by 2, right? 30 by 2 is 60. So 60 square units. 60 square units is the area. So how about B? B also the length of the perimeter is equal to 64, right? 16 plus 16, so it is 32. 32, okay, double 32, then you can get 64, right? So this is a square. And how much is the area? The area is 16 by 16, right? 16 by 16 is 256, right? 256. So much greater, right? By far greater than this one, right? This one only has 60 square units, and this one has 256 square units. So this is by far larger than that one. How about this one? This one is 20 plus 20, so 40, right? 40 plus 24, so 64, right? So the perimeter is 64. How much is the area? The area is 20 by 12, right? So 240. 240 still smaller than the square, right? Okay, how about this one? This one 8 plus 8, so 16. 16 plus 48, because 24 double 24, you get 48. 48 plus 16, so you get 64, right? So this one also has a perimeter of 64 units. So how much is the area? 8 times 24, so about 200, right? About 200, so it is 196. No, 92. 192, right? Okay, still smaller than that one, right? So this is slimmer than that one. So this is smaller than that one. This is the slimmest, the most slim one. This is the most slim one, right? So this one is the smallest, right? And this square is the greatest, right? So okay, so now you know. If you are required to enclose a rectangle, then with the given perimeter, if you enclose a square, then you get the greatest area, right? Okay, so you remember this rule. A square has the greatest area. A square has the greatest area. I mean, among rectangles, okay? Among rectangles. So a square has the greatest area. You remember this, right? Okay, this is only a rule that is given to you, so you just remember it in grade 9. And in grade 10 you can prove it using what? using a quadratic function, using a quadratic relation, you are able to prove that a square has the greatest area. Okay, got it, right? Okay, so let's move on. How about rectangles with just 2 sides? So, for example, if at college you are attending college in another city, not in this city, so you are far away from your home, and then in the summer you have to move out of the dormitory, the living building, the residence building of your university, of your school. You have to leave. Then your belongings must have a place to be held, right? You need to put away your belongings. So but for example, your friend's uncle has a warehouse, and you are allowed to put your belongings in the warehouse. However, you are asked to buy some things to enclose your belongings. So if you put your belongings, your things in the corner, then it is necessary just to enclose 2 sides, right? Because you want to save money. If you want, of course, if you are a rational person, then you will just buy things to enclose 2 sides, right? You will not be so silly that so silly as to enclose 4 sides, right? Okay, so you only enclose 2 sides. So for example, if you can buy 4 meters of fence, you can only afford in order to save money, right? So you can only afford 4 meters of fence, and you want the greatest area. Then what kind of shape are you going to enclose? A slim rectangle or a square? Okay, of course a square has the greatest area. Okay, remember that, right? Okay, in such a situation, also a square has the greatest area. A slim rectangle has a much smaller area. So don't use this. Please use this. Use a square if you have to enclose 2 sides or 4 sides. If you previously you had to enclose 4 sides, right? If you had to enclose 4 sides, then you would use a square. And now, if you are required to enclose 2 sides, then you still use a square, right? Okay, so how about a third situation? If, for example, this is a community center, and you want to enclose a skating rink, okay, a skating rink. So you use a fence, right? You use a fence to enclose a skating rink, but beside the community center, right? So do you still need to enclose 4 sides? No, actually you don't, right? If you enclose 4 sides, then this means you are silly, right? You are not smart anyway, right? Okay, so you only enclose 3 sides, right? 3 sides. This side is not enclosed, right? Because it is attached to your community center. So you enclose 3 sides. If you have to enclose 3 sides, then do you enclose a square in order to get the greatest area? Then do you enclose a square? No, actually no. Now a square is not the best. A rectangle is the best. A slim rectangle. How slim? Slim this way. If this is the width and this is the length, then the length is twice of the width. Then the rectangle has the greatest area. Got it, right? Okay. How about in front of a river? So if this is a river and you want to enclose your farm, And do you still want to enclose four sides? No, you are not so stupid, right? You are not so silly. You will not. So you will not enclose four sides. You will just enclose 3 sides, because the river, the bank of the river is not necessary to enclose. Okay, because the others will not invade your farm from the river. Okay. So if you need to enclose 3 sides, then the shape should be a slim rectangle, should not be a square, right? It should not be a square. And what kind of slim rectangle? The length should be twice of the width. Okay, if the width is 1 unit, then the length should be 2 units. Then such a rectangle has the greatest area. Got it, right? Okay, so if you enclose 3 sides, then a rectangle has the greatest area, not the square. Okay, so let's practice. So suppose you were a resident in New France in 1740, and you were interested in a lot in front of the St. Lawrence River. Okay, so this is the St. Lawrence River, and you were interested in this lot. So okay, a piece of land is called a lot, right? Okay, so the French government required you to enclose your property with a fence. Okay, you are required to use fence to enclose your lot, your property. Okay. You could only afford 800 meters of fence, and you wanted as much land as possible. Well, you were greedy, right? Of course, if it is legal, not illegal, if not illegal but legal, legally, then everyone is greedy, right? Okay, it is reasonable to be greedy. Okay, so if you want as much land as possible, it's reasonable, right? It's good. No, this even though although you are greedy, you are not bad, you are not evil, right? You are still good, a good person, a normal person, right? Okay. You could afford only so long of fence, okay, and you wanted as much land as possible. So how much land could you get at most? So you need to get land as much as possible, right? So the greatest area, right? The greatest area. Then you need to enclose this way, right? A slim rectangle. The length is twice as the fence, right? As the width, right? Okay. So let x be the width. Then 2x is the length, right? Okay. And the fourth side should not be enclosed, right? Because it is in front of the river. If you use the fence to cover this side, then the person is really stupid, because it's hard for you to get into the river, right? And it's hard for you to get water from the river, and it's not necessary, right? Because people will not invade your farm from the river. Okay. So now this side is also x, right? So x plus 2x and plus this x. So x plus 2x plus the final x is equal to 800, right? You can afford 800 meters of fence. So this is 800 totally, right? Okay. And then collect like terms. 4x, right? 4x is equal to 800. So x is equal to 200, right? You move this 4 from the top of the left to the bottom of the right. So 800 divided by 4, you get 200. 200 meters, right? So x is 200 meters. And then the length is 400 meters, right? Okay. So the area is equal to length times width. So the length is 400 meters times 200 meters. So you get the area 80,000 square meters, right? 80,000 square meters. Okay, so I could enclose at most 80,000 square meters of land, right? Okay, so this problem is solved. This is in theory, right? This is in theory. However, actually in history, in grade 9 geography, the geography of Canada, you learned that actually the long lots in Quebec actually are not in such shapes, right? They are actually very long, very slim, and the front on the river is very short, right? It's very short compared to the length of the lot. Okay, so this front is actually very short. This water front actually is very short. How come? Why? This is because the government had such a rule. Because people, was it the farmers, the residents actually were required to share the river, right? So if one family occupies a short distance along the river, then there can be many farmers or families living here, right? Okay, if one family takes all the front, all the water front, all the front of the river, then only few families can live here, right? So that's not good, right? That's unfair, and that's not for the government to levy taxes, right? Because if there are only few people live here, so what is the revenue of the government? The government cannot levy too much tax on the people, right? If there are many people, there are thousands or millions of people here, then the government can levy much tax, right? So the more people live here, the better for the government, right? So the government required the farmers to occupy as least as possible the water front. Okay, so the long lots actually occupy a little water front. And another reason is that in those years, the river was the only way of transportation, right? So if you travel from France to your home, then you only use a boat, right? You can only use a boat, and then you come along the river, right? In order for others to have access to the river, then you can only occupy a little, right? If you occupy too much for yourself, then how about the other people? The other people cannot have access to the river, right? Okay, so this is the reality, different from the theory, right? Okay. Then now we come to our second part of today's lecture. Okay, that is the maximization of the volume, okay, of bodies. So for example, this is a prism. This is also a prism, right? But a cube actually. This is a cube, right? But also a cube is also a prism, right? It belongs to a prism. This is a flat prism. This is a slim prism. This is a flat one, and this is a cube. Okay. So if actually they may not, right? I don't know, but I say we suppose that they have the same surface area. Okay, so this one, for example, has a surface area. This one has a same surface area, and this one also has a same surface area. So they three have the same surface area. Question: which one has the greatest volume or capacity? If they are containers, they are all containers, then which one has the greatest capacity? Which one has the greatest volume? Of course, this one, right? The cube. So the cube has the greatest. The cube has the greatest volume among all the prisms if they have the same surface area. Okay, then the cube has the greatest volume. Okay, and in another way, we express this. No, not express this in another way. Or you make containers another way. So if now this is a different if. Okay, if all they three have the same volume. Okay, if you make them all the same volume, actually they may not, right? But we say if. So we suppose that they all have the same volume. So which one has the smallest surface area? So this means if you are a manufacturer of containers, then in order to make containers to hold liquid of the same volume, then you want to save the surface area, right? Save materials, save raw material in order to save raw material. So you can lower your cost, right? So you can make more money, right? Okay. So if they all have the same volume, so which one has the smallest surface area? Of course, still this one, right? Still this cube. So a cube has the smallest surface area. So if they have the same volume, so all the prisms have the same volume, then a cube has the smallest surface area. If they have the same surface area, then a cube has the greatest volume, right? Okay, so you got it, right? And you can use this rule when you make things, right? When you solve problems, you can use this rule, right? Okay, good. So let's move on to cylinders. This is a slim cylinder, and this is a short one, and this is a flat one, right? Okay. So if right? If they have the same surface area, then which one has the greatest volume? Of course, this one, right? This one. So when does a cylinder has the greatest volume? Okay, this is a question, right? You know it, right? When this diameter, okay, the details, please remember, pay attention to this detail. Okay, when this diameter is equal to the height, so the diameter and the height make a square, then this cylinder has the greatest volume. Okay, so this is the greatest volume. Okay, now another if, a different if. Okay, so if they all these cylinders, all these cylinders have the same volume, they can contain the same amount of water. So which one has the smallest surface area? Again, this one, right? Same reason. Okay, again this one. And if you ask why, if you ask for the reason, then now I do not give you the reason. Okay, in grade 10 or grade 11, when you study the quadratic functions, then you can no, not actually, not quadratic functions. In the future, you can use that thing. You can use in grade 12 when you study calculus, the first part, differentiation. Then you can prove that, okay, such a container has the greatest volume, and if they have the same volume, such a container has the smallest surface area. Okay. So, question: in reality, in practice, in industry, this is bottles of ice wine, right? And these are bottles of red wine, right? Okay. So, why don't the manufacturers use bottles in such a shape? Okay, in such a shape. Why don't they use such bottles in such shape, but in a slim cylinder? So they use slim cylinders. Why? The first reason is slim cylinders are more good looking, right? They look more beautiful. Okay, so this is the reason they look more beautiful. A second reason is this. Ice wine is more expensive, right? Ice wine is more expensive. It is harder to make ice wine. Okay, so ice wine actually is very precious. If it is precious, then the less volume, the better, right? I mean, for a seller, if you sell for the same price, then you provide the less content, the better for you, for the seller, right? Okay, so for the seller, for the manufacturer, okay, the manufacturer of the content, I mean, the manufacturer of the ice wine, because there is only a little ice wine there, but you want it to appear to be much, then you use a slim bottle, right? If you use a short bottle, then it will contain lots of ice wine, right? But you don't have so much ice wine, so you have to make a very small sized bottle, right? If you provide a very small sized bottle, then the customer will not be glad, right? Okay, so you use a slim bottle, so it appears to be a lot of ice wine inside. Actually, the volume is very small. Okay, so this is commercial techniques. Okay, these are commercial techniques. First, they look more beautiful, so they can attract the eyesight of the customers. Second, they look to be a lot. Actually, there is only a little, so the price can be high, but people still buy, right? Okay. For this red wine, because red wine is not so expensive, right? Not so hard to make. So the manufacturers can provide a lot. So they use the bottles that are less slim, right? So they can use fatter bottles. Okay. Okay. If your content is really cheap, very cheap, then you usually use such containers, right? In order to save the raw material to make the container, right? In order to save the raw materials to make the container, so you can save money, right? Okay, that's why when you buy large tanks of, for example, what? For example, bleach is very cheap, right? So the containers are round and fat. Okay. Or the detergent is also very cheap, so they use such shapes to make their containers, right? Okay, so okay, so this is the end of this unit. Okay, thank you, bye, have a nice day and good luck in your final exam. And actually next time we just practice. If we have next time, I think we should have next time. Okay, next time I will ask you to practice some review questions, okay, but not lectures, just review questions. So I will give you some homework for you to practice. Because practice makes perfect, right? Okay, thank you. Good luck in your final exam, and good luck in your career. Good luck in your studies. Okay, thank you. Thank you, and I bow to you. Okay, thank you. Bye.